In this video, we are going to learn the basics of congruent triangle proofs, and we are going to start off with some baby steps. So, for problem number 1, we are given that AC is congruent to DE. So let's mark that. So AC is congruent to DE. Next, we are given that angle A and angle D are right angles. So let's go ahead and mark that as well. So angle A is a right angle, and angle D is also a right angle. But that means that something is congruent to something. Don't overthink it. If A and D are both right angles, of course that means that angle A is congruent to angle D. They are both 90 degrees, so that automatically makes them congruent. So watch out for that. When you have two right angles, that automatically makes them congruent. In addition, we always know that vertical angles are congruent. Vertical angles are these angles that form an X, like this angle and this angle. Okay, so we need to name those angles. It's going to take a three-letter name. So the angle on the left is angle ABC. So we can say angle ABC is congruent to angle, and this angle on the right is DBE. So those angles are congruent. Now we have enough information to prove that the two triangles are congruent. Which of the 5 ways can we use to prove that the two triangles are congruent? Please remember that the options are side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse leg. That one is only for right triangles. So those are the only 5. So looking at this problem, I see that we have a right triangle. So the first thing you should do is ask yourself, is it hypotenuse leg? So hypotenuse leg question mark? Well, focus on one triangle at a time. So look at this yellow triangle over here. Do I have a hypotenuse marked? No, the hypotenuse is here across from the 90-degree angle. Notice that it is not marked. So that means this cannot be hypotenuse leg. So let's think about the other 4 choices. I notice that we have 2 angles and a side. So that means this is either going to be angle, angle, side, or maybe it is angle, side, angle. It all depends on whether or not the side is between the 2 angles. If the side is between the 2 angles, it will be angle, side, angle. Otherwise, if the side is not between the angles, then it will be angle, angle, side. Well, here's the first angle, and here's the second angle. Here is the side between those 2 angles. Is that the angle is this the side that's marked? No, the side that's marked is way over here. So the marked side is not between the 2 angles. That makes this angle, angle, side. So this is an angle, angle, side situation. Now we need to make a congruence statement. So triangle ABC is congruent to triangle what? The order of the letters matter. First we see angle A, but looking at the markings, angle A corresponds with angle D. Those are both right angles. So we're going to say angle D. And next we see angle B. Well, angle B of the yellow triangle corresponds with angle B in the white triangle. So I'm still going to do angle B. And so that just leaves angle E. So that's it for problem number 1. Look at problem number 2. We are given that CB is congruent to EB. So here is CB, and here is EB. We are also given that angle C is congruent to angle E. So angle C is congruent to angle E. Vertical angles are always congruent. That means that this angle is congruent to this angle. Using the three-letter name, the angle on the left is angle ABC. And the angle on the right is angle DBE. So, armed with this information, we can now prove that the two triangles are congruent. Focus on one triangle at a time. So, look at this yellow triangle, for example. Which of the 5 ways will prove that these two triangles are congruent? Well, let's see. I see that we have 2 angles and a side. So that means this is either going to be angle, angle, side, or it will be angle, side, angle. If the side is between the 2 angles, it will be angle, side, angle. Otherwise, it will be angle, angle, side. So, is the side between the 2 angles? Well, here's one angle that's marked. Here's another angle that's marked. This is the side between them. Is that the side that's marked? Yes, it is. This is the marked side. So the side is between the 2 angles. That makes this angle, side, angle. All right, so we can go ahead and say angle, side, angle. Now we need to do the congruent statement. Triangle ABC is congruent to triangle what? All right, I'm going to do this over here so I can stay sort of zoomed in. So we want to say triangle ABC is congruent to triangle. Well, I can see that these the yellow triangle and the white triangle are mirror images of each other. So angle A corresponds with angle D. Notice that both of those are blank, no markings. And then angle B of the yellow triangle corresponds with angle B of the white triangle. And then angle C with a single swoop corresponds to angle E with a single swoop. So triangle ABC is congruent to triangle DBE. The order matters. All right, let's take a look at problem number 3. First, we are given that BC is congruent to EA. All right, so BC is congruent to EA. That's given. We are also given that BA is congruent to ED. All right, so BA is congruent to ED. Furthermore, we are given that A is the midpoint of CD. And that's going to cause something to be congruent to something. Let's see. A is the midpoint of CD. I want you to focus on CD first. So here is CD. If A is the midpoint, all right, meaning this is the midpoint right here, that means that CA is congruent to AD. So that's what we're going to put in the blanks. CA is congruent to AD. Now it's time to say, what rule proves that the two triangles are congruent? Well, clearly this is going to be S, 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 side, 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 because focusing on one triangle at a time, we just have 3 congruent sides. Now in the top line, we need a congruence statement. Triangle ABC is congruent to triangle what? Let's do that over here so I can stay zoomed in. So we have triangle ABC is congruent to triangle. Okay, you can tell that the yellow triangle and the white triangle are oriented the same way. You could imagine that you got the white triangle by just sliding the yellow triangle over to the right. So the angles are in the same order. So notice that angle A is in the same position as angle D. So I'm going to start off with angle D. Then angle B is in the same position as angle E. And then angle C of the yellow triangle is in the same position as angle A of the white triangle. All right, so triangle DEA. Problem number 4. All right, a similar picture, but this time we are given that BA is congruent to ED. So BA is congruent to ED. We are further given that angle BAC is congruent to angle D. Okay, angle BAC is this angle right here, and that's congruent to angle D. In addition, we are given that angle C and angle EAD are right angles. Okay, so angle C is a right angle, and so is angle EAD. So when you're given two right angles, you automatically know that they are congruent. So this is not a trick. If angle C and angle EAD are right angles, that means, guess what? Angle C is congruent to angle EAD. Which makes sense. They are both right angles, so of course they are congruent. Now, this is enough information for us to say why the two triangles are congruent. So, as soon as I see that there is a 90-degree angle, the first thing I want to ask myself is this going to be hypotenuse leg? Well, focus on one triangle at a time. Look at the yellow triangle. Do we have a hypotenuse? Yes. All right, across from the right angle, we have a mark. This is the hypotenuse. Check. Do we have a leg? No. A leg would be either of the other two sides, and neither of the other two sides are marked. So this cannot be hypotenuse leg. So I'm going to view this as just a regular triangle. So I'm noticing that we have two angles and one side. So that means this will either be angle, angle, side, or it will be angle, side, angle. All right? Those are the two ways to have two angles and one side. If the side is between the two angles, then it will be angle, side, angle. If the side is not between the two angles, then it's angle, angle, side. So really focus on the two angles. One angle that's marked is angle C. And again, I'm just looking at the yellow triangle. One angle is angle C, the other angle is angle A. The side that is between these is the side that connects these. So this is the side that's between C and A. Is that the side that is marked? No. The side that's marked is way over here. So the side is not between the angles. That makes this angle, angle, side. So we're going to put angle, angle, side. Now it's time for the congruence statement. So we're doing triangle ABC is congruent to triangle what? Well, this is going to be the same as the last problem. These triangles are oriented the same way. So angle A comes first. That's in the same position as angle D on the white triangle. Next comes angle B. Yellow angle B is in the same spot as white angle E. That only leaves the white angle A. Okay, because the yellow angle C corresponds to the white angle A. So once again, triangle DEA. Okay. Looking at problem number 5. We are given that AB is congruent to CD. So AB is congruent to CD. We are also given that AD is congruent to CB. All right, AD is congruent to CB. Of course, the shared side is congruent to itself. So we can go ahead and mark that. Okay, oh, by the way, so the congruence statement that you make when we mark the shared side, we can say that CA is congruent to CA. All right, I know it feels a little bit silly, but this is how you would make a statement in a proof. When you have a shared side, you just say that the side is congruent to itself. So anyway, if you look at one triangle at a time, you can tell the reason that proves these triangles congruent. So it should be obvious that this is side, side, side. So over here, I'm going to say side, side, side. Now it's time for the congruence statement. This is tricky for students. A lot of students will get this wrong. So let's be as careful as we can. So we have triangle ABC is congruent to triangle what? Can you see that yellow angle A is across from the double tick mark? So which white angle is across from the double tick mark? Well, that's white angle C. So yellow angle A corresponds with white angle C. So we're going to put white angle C first. Next it's time for yellow angle B. Yellow angle B is right here. That is across from the triple. Well, white angle D is across from the triple, so D comes next. So looking at the white triangle, we have C and D so far. So that just leaves angle A. But look, it does make sense because yellow angle C is right here. It's across from the single. Which angle is across from the single on the white triangle? White angle A. So yellow angle C corresponds with white angle A. Anyway, so it's congruent to triangle CDA. Okay, what I just did right there is one of the hardest things to do. A lot of students struggle with that, so we're just going to keep practicing. So look at problem number 6. We are given that angle BAC, let's focus on that, all right? Angle BAC is this angle right here. So we're given that this is congruent to angle DCA. Angle DCA is this angle right here. Angle DCA. We are also given that angle B and angle D are right angles. So angle B and angle D are right angles. So that automatically means that angle B and angle D are congruent. So we will just say angle B is congruent to angle D. And then the shared side is congruent to itself. So let's mark that. And the shared side is a segment CA. So we will say that CA is congruent to CA. So this should be enough information for us to prove that the triangles are congruent. Let's go ahead and focus on one triangle at a time. All right, so let's focus on this yellow triangle. So which of the 5 methods will prove that these triangles are congruent? I'm noticing that this is a right triangle. So the first thing you should do is ask yourself, is this going to be hypotenuse leg? Well, I see that we have the hypotenuse marked. All right, it's the double mark across from the right angle. Do we have a leg also? No, a leg is one of the other 2 sides. Neither of the other 2 sides are marked. So we have a hypotenuse but no legs, so it's not going to be hypotenuse leg. So we're going to treat this as a regular triangle. I'm noticing that we have 2 angles and a side. So this is either going to be angle, angle, side, or it will be angle, side, angle. It all depends on whether or not the side is between the 2 angles. If it is, it will be angle, side, angle. If the side is not between the 2 angles, then it is angle, angle, side. So, is the side between the 2 angles? Well, here's one angle, here's the other angle that's marked. Here's the side between those 2 angles. Is that the side that's marked? No, the marked side is way over here. So the side is not between the 2 angles, which makes this angle, angle, side. Now it's time for the congruent statement. So yellow triangle ABC, yellow triangle ABC is congruent to. So this will probably wind up being the same statement as last time because it's oriented the same way. But let's go through the motions for practice. So this will be congruent to triangle what? Well, angle A of the yellow triangle, see the single swoop? So that corresponds with angle C on the white triangle. So boom. Now look at angle B. On the yellow triangle, that's the right angle. So on the white triangle, that's going to be angle D. So we used up C and D, so that just leaves angle A. Okay, so triangle CDA. All right, moving on to problem number 7. We are given AC is congruent to DC. So AC is congruent to DC. Okay, this is tricky. We are given that segment CB bisects angle ACD. Be careful. We know that bisect means to cut in half. Focus on angle ACD. Angle ACD is right here. ACD. This is the angle that is being bisected. This is the angle that's being cut in half. So that means that this part of the angle is going to be congruent to this part of the angle. Now we need to fill in what is congruent to what. So we need to name these 2 smaller angles. So we're going to have to use the 3-letter name. So for example, the angle at the top is angle ACB. So we can say angle ACB. And the angle at the bottom is angle DCB. The shared side is obviously congruent to itself. So let's go ahead and mark that. Boom. And that means that CB is congruent to CB. So segment CB is congruent to segment CB. This should be enough information to make to say how to prove that these triangles are congruent. Focus on one triangle at a time. So, I see that we have two sides and an angle. So this is either going to be side-side angle, or it will be side angle side. Now, side-side angle is not a thing. It does not prove that triangles are congruent. It's not one of the options. So we really are proving that these triangles are congruent. So if this is going to be a fair problem, it really can't be side-side angle. That's not one of the options. So we kind of know it's going to be side angle side, but if you look at it, it makes sense because the angle is between the two sides. All right, see how this angle is between these two sides. That's what makes it side angle side. So we can go ahead and put that down. Now it's time for the congruence statement. All right, so triangle ABC is congruent to triangle what? Well, you might be able to tell that these are mirror images of each other over this line, all right? These are like reflections of each other. So you can see that angle A corresponds with angle D, which is the reflection of it. Okay, and then angle B is next. Well, the yellow angle B is the reflection of the white angle B. So I'm still going to just have angle B. And then when it comes to angle C, well, we have those marked even. So the yellow angle C corresponds to the white angle C. So triangle DBC. Okay, last problem. We are given that CB bisects angle ABD. So be careful. Start with angle ABD. It matters which side you're looking at. So ABD goes from A to B to D. That is the angle that is being bisected. Bisect means cut in half. So if we cut this angle in half, that means this piece is congruent to this piece. So we need to go ahead and say, we need to name these angles so we can say that something is congruent to something. The top angle is angle ABC. So we can say that angle ABC is congruent to angle. And now comes the bottom angle. Angle DBC is the bottom angle. Angle DBC. What else do we know? We're also given that angle A and angle D are right angles. So this is a right angle and this is a right angle. Well, guess what? That means that these are automatically congruent. So we can just go ahead and say angle A is congruent to angle D right away. And then the shared side will be congruent to itself. So we can mark that. And so that's CB. So we can simply say that segment CB is congruent to itself. So this is enough information to prove that the two triangles are congruent. Just focus on one triangle at a time. This is a right triangle. So ask yourself, is this hypotenuse leg? Well, we have the hypotenuse marked, but neither of the legs are marked. So it's not hypotenuse leg, but always ask yourself. So looking at this as a regular triangle, I see that we have two angles and a side. So that means this is either going to be angle, angle, side, or it will be angle, side, angle. It all depends on whether or not the side is between the two angles. If the side is between the two angles, then it's angle, side, angle. If the side is not between the two angles, that's when it's angle, angle, side. So is this side between the two angles? Well, looking at the yellow triangle, here's one angle that's marked. Here's the other angle that's marked. If I connect the dots, it shows me the side that's between them. Now, is that the side that is marked congruent? No. The side marked congruent is way over here, not between the two angles. So, since the side is not between the two angles, that makes this angle, angle, side. So now we can make the congruence statement. Triangle ABC is congruent to triangle what? All right, this is probably going to be the exact same thing as the last problem because they are oriented the same way, but let's go through the motions for practice. So triangle ABC is congruent to triangle. All right, the yellow angle A, we're starting with angle A. The yellow angle A clearly corresponds with the white angle D because those are both 90-degree angles. The yellow angle B has a single swoop. That corresponds with the white angle B, which also has a single swoop. And that just leaves the white angle C because we already have D and B. So triangle DBC. And believe it or not, guys, these are proofs that we've been doing. All right, they're sort of in a flow chart form, but these are basic proofs. In coming videos, we will do more complex proofs and we will begin to do them in 2-column form. But I think it'll be a lot easier now that we've done the baby steps.